1.
Hi, everybody. Welcome to our conversation tonight with Glenn Grossman, esteemed epidemiologist with over 20 years of experience. While pursuing his doctorate in epidemiology at UNC Chapel Hill, Glenn served as an epidemiologist on staff at the UNC Infectious Disease Clinic for 2 years and taught epidemiology along with advanced analytics at Duke Medical School and at UNC. He has been involved in epidemiology forecasting and advanced analytics with Bristol Myers Squibb, Sanofi, Novartis, Medicare, Medicaid, Veterans Health Administration, Military Health Service, the CDC, and other programs within the United States and abroad. All views expressed today are his own. So thank you to everybody. You keep sending in really terrific questions. Keep sending them. Glenn has worked hard to prepare our conversation tonight, and we'll be taking a deep dive into lots of your great questions. If you have questions or you'd like to comment as part of our conversation tonight, please use your chat button at the bottom of your screen and send me a message, and I'll do my best to weave you and your question into our conversation. Okay, Glenn, take it away. How are things looking at home and abroad?
Thanks, Rebecca. Here, let me share. Whoops. Share. All right. In fact, let me start with this one. So things are looking a lot better week by week in the United States. In fact, when you look at the high level, let me start up here. You can see that at the aggregate level across the United States, this current surge, we're continuing to fall. We're not falling as fast as we did back in February at the last surge. It's a slower descent, but we are continuing to go down. A lot of us think that we're going to start to see an increasing number of cases as the seasonality is changing now. And in fact, we're already seeing there's a bunch of states who are not out of the woods yet. So for instance, when you look, here's the CDC's map. When you look here, you can see that there's a bunch in dark blue that are still doing pretty poorly. And then there's the lighter blue that are doing better, but still not doing great. What's interesting is that when you look at where the ones that are doing poorly are, they tend to be in the northernmost regions of the country at this point. And so then the question is, will these start to descend now that it's getting colder and colder across the country? And then we'll see more. Interestingly, so when you look here, I like looking at this view. This is the change, the 2-week change in cases, the places where it's really gotten the most. So the United States as a whole has gone down by 24%, but in Vermont, Maine, New Hampshire, it's gone up 9%. Virgin Islands, Colorado, Connecticut, still going up. When you look at hospitalizations, there's been some big jumps. So for instance, New Hampshire has gone up 50% in the last 2 weeks in hospitalizations. Vermont's gone up 25%, Maine 23%. So you can see that there's this clustering in that region, but across much of the north, you can see when you look at a county by county level that we are not out of the woods in a bunch of states. So even though the aggregate looks good, there are a lot of states that are still struggling and getting worse. And so the question is, over the next couple of months, based on the seasonality change, will that expand? What will that look like? It's still an open question. How will flu come in? So here's the figure that is looking at flu. The green, so dark green here and light green, represent influenza. So the flu, influenza B and influenza A, different kinds of flu. And so you can see that the flu, based on all the restrictions we've been having over the last year or two, the flu has been virtually eliminated. There's been very, very little. In fact, so you can see it's been 0% for a long time. However, over the last few days, you can see if you check on the screen, it's hard for me to move the mouse up here. Every time I move the mouse, the box moves. But look at the box where it says influenza A, influenza B. When I come to the far right, it's still very low, but you can see that influenza B and influenza A are approximately 0.3% each. And that's been, over the last couple of days, that's been jumping up. So even just a week ago, it was at 0%. So a week ago it was 0.1% rather. But so the fact that over the last couple of days it's continued to rise means that we are now beginning the flu season, and so everyone needs to get vaccinated. And there's this open question of how bad the flu season will be this year and what that overlap will look like with COVID, and we still don't know yet. So here's what we look like there. In terms of the vaccines, so a lot of eyes are on the booster shot now. So far, around 7% of the entire population has already gotten their booster shot. Remember, a lot of people haven't been eligible yet. So far, technically, until this past week, only people who got the Pfizer were eligible for a booster, and only a subset of them. But now it's been expanded to Moderna, Moderna and Johnson & Johnson in addition to Pfizer. And we'll talk about that in a little while. But you can see among people age 65 and over, we don't have enough people who have gotten their booster shot yet. It's only 17%. Among people age 50 and over, it's 23%. And the reason is that a lot of people, the reason why the 50 plus is larger than the 65 is a lot of people who are eligible were eligible based on the frequency that they would come into contact with other people who are at high risk. So it wasn't just the high risk people getting vaccinated, it's also physicians, teachers, other people who are at high risk of exposure from others. All right, and when you look around the country, so right now we have it, so 65 and over is fine. You can see that there are some states that are doing better than others when it comes to the booster shot. However, the people getting the booster shot were the ones who already were vaccinated. So when we look at this population, they've already been self-selected into getting vaccinated. So you'd expect them to be the highly motivated people. The ones who are not getting vaccinated, so I don't have a way of showing this easily, but when you look here, this is people who have received their full vaccine dose. You can see that in these areas, so for instance, the light green, there's still a lot of people who have not been vaccinated at all. So right now we have, on average, in the United States, we have around 57% have been, of the entire population have been fully vaccinated. Among people age 18 and over, it's 69% essentially. And so when we look here at 18 and over, so it was just around 69%. You can see that there's a bunch of states that are a lot less than 69%. And then there's a couple, particularly in the Northeast, that are far above 69%. So there is still this variation. And if you recall, this area in the South got hit very hard just a month ago or so. And so there is this open question in the next couple of months, will they get hit again in the winter? And I think that's still an open question. I think most of the models now are suggesting that the coming winter won't be nearly as bad as what we just had. So in the last month or two, in terms of the Delta surge, and won't be as bad as what we had last year. So I think we're out of the thick of it for most of the states and most of the country. However, like I said, that's an aggregate statement, and so there's still going to be lots of counties, lots of hospitals that are going to be overwhelmed, lots of people who are still going to get sick and who are going to die, unfortunately. And so even though the numbers are coming down in general, the country is not out of the woods yet when we talk about the big picture. All right, now let's talk about kids. So I like looking at this. The CDC breaks it down into regions, the United States into regions. There's 10 regions. 1 and 2 are the Northeast. You can see region 10 and 8 are also in the North, so the Northwest and the Midwest, the North. And then 5 is also the Minnesota, Wisconsin, Michigan area. And so those are in the North. In the South, we have 4, region 6, and the West is region 9. So based on that, when you look now of where it's starting to get big in the country, you can see region 1 and region 2. Again, this was the Northeast. We do have a big spike in the 5 to 11-year-olds that we're seeing. Don't pay too much attention to the gray bar here because that's where the data is weak. So if it starts to look like it's coming down, we can't really interpret it that way because it's just basically a lack of reporting. But basically what we see is this big surge in region 1 A similar surge in region 2. Again, it looks like it's coming back down, but you can't interpret that because it's in the gray box. But it's quite high. So we are experiencing a surge in kids going back to school. And the surge is not as big as what we're seeing in the 12 to 17-year-olds. You see that the numbers are a little bit less there. However, there are still quite a lot of kids who are under 17 who are getting infected. Region 5, we're seeing similar, although it looks like it might be coming down a little bit more. It's outside of the gray box. Region 10, we're also seeing going up again, and region 8 it's going up. In much of the country, we're still seeing it high. So if you look at 10% as a benchmark and just seeing if it's bad, how bad it is, where the kids are above 10% relative to the entire population of people getting sick, you see there's a lot of regions that still are above 10% here. And so the big question has been, with the students getting sick, will they increase the spread to their parents and to other people around who they live with and then in their counties? And I think we are seeing some of that, but not as much as it could have been. I think a lot of schools really are enforcing the mask mandates, shutting down at least the classes or the classrooms when some kid is infected, just to reduce the spread. I think there is testing going on, so I think that's why we're not seeing as big an outbreak as we could have been. And in the South, where they weren't doing that as much a month or two ago, so say region 4, we were seeing more of this spike, and that was coincident with the surge that was going on in the area at the time. So looking back in August and September, with this, I think this spike was associated. It's unclear whether the spike was causing it or whether it was just part of the surge going on naturally in the community there. Probably a little bit of both. But now the big question, because when you look at some of these, there isn't really a lot going on. So when you look at New Jersey, look at New York, which was region 2, there's not really a lot of red there in terms of what's going on generally. And so yet when you look at the kids, which is region 2, there is this surge that you see. So it's still this open question how that's going to evolve in terms of spreading to different age groups. Again, the vaccination rate has been quite good in New Jersey, so that's probably preventing much of the spread. 78, 76, 79% of people over the age of 18 have been fully vaccinated. And plus, on top of that, you have a bunch of people who are at this point have gotten the boosters. So that's the open question. I'll just briefly mention, this has come up before, but I'm not going to talk about it much later. This question of red states versus blue states. And we definitely have seen a major difference in terms of vaccination rates by red versus blue. So blue states tend to have far less unvaccinated people. Red states tend to have a lot more unvaccinated people or people who are not fully vaccinated. When it comes to death rate, the red states now, the death rate is quite a bit higher from COVID than in blue states, simply because the vaccines are helping a lot and keeping people, even if they do get infected, keeping them out of the hospital and keeping them alive. Similarly, when you look at specific counties at a county by county level, it looks very similar. So even when you break out the blue versus red states, you still see that even within states, the red counties are doing far worse than the blue counties. And this is consistent, relatively consistent across the country. And so, yeah. So anyway, I'm not going to talk much more about that. It's just, that is what it is. When you politicize these things, it has consequences. All right. Now let's look globally. So interestingly, here's United Kingdom, and UK, you can see, is going up again. And this is totally unexpected for a lot of us. In much of the world, it's been going down after all the vaccines. Like, so for instance, here's United States, here's Germany's going up a little bit. Here's Australia, they've had a little bit of surge. France has been coming down. A lot of countries have been going down. Brazil is South America, or rather Southern Hemisphere. So so we know there's a seasonality here, so we expect it to go down just because of the seasonal thing here. India is following their seasonal pattern that they've had in the past. But so UK, it's highly weird that United Kingdom is going up again. And so the question is, well, what's going on there? first, before I go on, let me just say that that's confirmed cases. If you look at deaths or hospitalizations, their deaths are far, far lower. So even though their cases have been going up, you can see that they're, so here's, let's just restrict it to the US and UK just to make it easier to see. All right, so you can see that here's the UK deaths from COVID. It's quite a bit lower than the United States. But remember, we just looked at cases. And so if I bring it back to cases, the UK cases were quite a bit higher than the United States. So clearly the vaccines are working. At some point, we're gonna have to get comfortable with this idea that people are still gonna get infected and spreading it, but the hospitalization and the death rate are gonna be going down. So for instance, here's the hospitalization. So right now, US and UK have a similar hospitalization rate per million people. But again, that's in comparison to the cases, where UK's caseload was quite a bit higher. And yet, despite all the increase in infections, the hospitalization is still on par with the United States. Still, when that's still somewhat high. And so you'd expect with vaccines that it would be even lower than that. And the problem with United Kingdom is that there are some holdouts in getting vaccinated there too. And similar to what we're seeing in the United States, the ones more likely to be hospitalized are the ones who are unvaccinated. So even them, even the people who are unvaccinated, over time, there's going to be less and less susceptible people who are because even the vaccinated people, once they're infected, will become less and less susceptible. And so,
Glenn, I'm just going to pause right there. Harry has a great question. Harry, could you please unmute or I can ask that. Oh, there you go.
Yes. So the question, you want to hold it? The question is, Israel was a country that was significantly more vaccinated than the rest of the world. So time has gone by. What has happened to the data coming out of Israel about people getting their boosters and about the infection rate and the hospitalization and death rates?
all right, so that's a great question. Here's Israel in comparison. This is, yes, so cases. So this is from January when the vaccines really started getting administered around the population. You can see that Israel, once they started opening up, did have a surge from Delta, but it's come down tremendously and the numbers are quite lower now. They're a lot lower than the United States. Israel is a much smaller country, clearly very different than the United Kingdom. When you look at hospitalizations, I don't know if they're reporting them. Yeah, they are. You can see that Israel is doing far, far better than US or UK. And when here's the vaccine rate just to show you people fully vaccinated. So you can see that UK and Israel are pretty close. There's also some vaccine hesitancy in Israel as well. Israel peaked earlier, and then United Kingdom peaked a little bit later. There were a couple differences. United Kingdom spread out the time between dose 1 and dose 2. And we know now that the longer you spread out the time between dose 1 and dose 2, the more efficacy there is, the more protective it is. So they were trying to balance getting more people that first vaccine, the first dose, whereas Israel tried to get out more people fully vaccinated earlier. And so now UK seems to be benefiting from that a little bit. Although when you look at the curves, it looks like Israel is doing just fine. And so that's good. All right, let me just I'll dig into UK just for a second in terms of what's causing UK. So UK totally eliminated their mandates. When you compare them to the rest of Europe, there's a lot less people wearing masks in public spaces. There's a lot less people avoiding public transport. There's a lot less people avoiding large gatherings and a lot less people avoiding crowded spaces. Similarly, Similarly, when you compare children, a lot of other countries in Europe now have vaccinated their kids age 12 to 17, whereas UK has fallen well behind. Even though they were better at vaccinating adults earlier, the 12 to 17-year-old bunch are largely unvaccinated. And so because you have this large susceptible population in the context of reopening and all this additional exposure, this is what's driving a lot of the surge. A lot of the kids are getting infected and then they're going on and infecting the adults. And so that is, I mean, seems to me a pretty transparent or straightforward explanation for what's going on. All right, a couple other things, and then we'll get into questions. So in terms of the Delta variant, we've talked about this previously, where I said the Delta variant was so contagious that it was spreading so fast that it was wiping out all of the other variants. And so this is good news in a sense. I mean, it's bad news of how contagious it is, but the good news is that there's far, far less variant diversity. So in terms of breakout of other variants, we don't really have to worry about them as much because we've sort of made a lot of them extinct. When you look at the table, so this is the Delta variant, you can see a lot of countries, it's 100% of the country is Delta at this point. There are only less than 10 countries around the world that are reporting data that have less than 100% Delta at this point. And that's including, when you look at US, 99.96, UK 99.99, that's essentially fully Delta. There's still some remnants that are still circulating, but it's almost entirely Delta. We'll probably talk in a little while. There is this new strain. So now Delta has had children and grandchildren. There's a bunch of different grandchildren of Delta that people have been calling super Delta or Delta plus. And so there's multiple of these variants now that are called Delta plus, and they're not the same one. So the term is being used for a few different variants now. But we'll talk about that because there has been one variant of Delta plus. It's the AY.4.2 variant that does seem to be even more contagious than the original Delta. But Delta is so contagious that no one's really worried about that much because it's already it's sort of reached this threshold of how contagious it is that everyone's going to already get it. So it's not going to really change anything very much. All right, I hit that. Let me show a map here of confirmed cases. All right, and so just at a glance, you can see we are seeing the seasonality. So in the summer, we're seeing some more cases in the Southern Hemisphere. Now we're shifting into more of the Northern Hemisphere. And so, yeah, we are talking about this virus becoming endemic rather than epidemic. And so probably within the next 3 to 6 months, the surges are going to start to really go down a lot. There's still going to be infections that are going on, but we're not going to really see these big hospitalizations or deaths that we were seeing previously. And at that point, the infections will continue to spread. It's not going away anywhere. When the mandates go away, we're all likely to just be infected at some point, perhaps repeatedly over the next 3, 5, 10 years. But it's not going to be something to really worry about because at this point, there's going to be a lot less mutation. And it's going to, because we already have some immuno memory, it's going to keep it in check a little bit. And then we're just going to get reinfected, and it's probably we'll talk about that in a few minutes. I think there's a question on that. All right, this I will not talk about. So in terms of what the next few months look like, green is what's the most likely. You can see that we just came out of the surge where it peaked in September, and now we're in mid-October. It's going to probably continue going down for a few weeks on the aggregate level. Again, some states are not doing well, and some specific states are increasing, but at the aggregate level, it's going to continue going down. But then the green is what's probably most likely, whereas we hit the typical cold and flu season, we're going to start to go up again. Again, no one's expecting it to really go up as high as what we had in September or what we had last year, but just because of the seasonality of it, there's still a lot of people who are susceptible, and so we're still going to be seeing a slight increase. However, so here's this is infections. Let's go back to here's deaths. We expect that deaths will increase a little bit too, but again, this is still going to be even less than what we had in the previous spikes. So that's really good news. There's a bunch of people who have been forecasting this with different models, and you can see generally where we expect that childhood vaccination is going to start within the next couple of weeks. So for kids under the age of 12, So age 5 to 11 will probably become eligible within the next couple of weeks. And so you can see that a lot of the models are not even expecting an additional surge based on the seasonality. So there is some uncertainty there, but there is also some variation in the models in terms of what they're predicting. And that is not that. All right, so yeah, so that is it in a nutshell.
Thank you, Glenn. Very helpful. So let's continue talking about children. Your last map showed us the prediction of what you thought most likely with kids getting vaccinated under 12. Where are we with that? And what would you say to parents who are taking the stance, I'm just going to wait and see?
Okay, so there's a couple of questions there. So first I'll say, so here's the process just to refresh everyone's memory. First, you have the real world data that's reported out. Then the VRB PAC meets, that's the Vaccine Related Biological Products Advisory Committee. Then the FDA. Then the CDC Advisory Committee, this ACIP meets. Then the CDC approves it, and then it is released to the public. Where are we? So right now, I think the FDA is meeting, this is tomorrow. So today is October 24th. So on Tuesday, October 26th, the FDA, the VRBPAC is meeting. So that's this one. So this is the 26th. So I have some information we'll be talking about that this is where it comes from here, based on this one. So that's this one. Once they meet, assuming that they approve it, then the FDA will then approve it and sign off on it. And then once the FDA signs off on it, then the ACIP would then review it. The ACIP already has a meeting on their books to review it, and the meeting is scheduled for November 2nd and November 3rd. So that means that as soon as they approve it, very quickly, probably within the next 24 hours, the CDC would then give their stamp of approval. And as soon as that's done, it would be shipped out to the public. The reason why the new doses need to be shipped out separately is because currently the Pfizer dose, and again, this is only Pfizer that's being released so far, because it's only Pfizer that's reported out on their clinical trials. Currently, the Pfizer dose is 30 micrograms, and the child dose for kids 5 to 11 are 1/3 of that, so it's 10 micrograms. And so in addition to being a smaller volume, they're smaller needles because they're much smaller kids, so that you don't want to scare the kids and you don't want to damage the kids. So they're much smaller needles that are used in the syringes. So they are being shipped out separately. Additionally, when we got our vaccines, mostly for the adults, we went to clinics or to other large mega sites where they were being administered. For kids, in order to make it so that it's more, I guess, less frightening, they're going to be largely rolled out to pharmacies, pediatricians' offices, and schools and other local sites. I think I have it. Community clinics, community health centers, schools, and to a lot more local places. But in particular, the pediatricians, I think a lot of people, not every pediatrician is going to get it. They're going to be restricted because they still have the same restrictions in terms of ensuring that they keep it cold enough and whatever in terms of the distribution. Not all the pediatricians are going to have patient populations large enough that they can really justify bringing the vaccines in there, but a lot will. And so that's going to be really helpful. So right now, there have been a bunch of studies in the kids. The first that we talked about last week, we're looking at the safety issues in terms of the side effects and looking for any safety issues which weren't found. And that's good. Now, the new data that was just released is looking at efficacy. So how effective is it? And so let me just review what they had found on safety. So basically the safety was essentially the same. In terms of any adverse event, it was roughly the same. Right here, we're looking at 11.5% compared to 9.5% in the placebo. But when you look at severity, they were pretty much identical and nothing life-threatening to worry about. In terms of the effectiveness, what they found was that the vaccines were 90.7, so let's say roughly 91% effective at preventing COVID-19 in kids. There weren't enough cases of severe COVID or hospitalization, because remember, it's a lot rarer in kids. And so they only looked at Does it say here? I think we just saw over here, they were looking at 2,268 kids. And so among these 2,268, was it 2,000 or 10,000? It was a large enough number that that they would have oh, here it is. So it was the 2,000 number rather than the 10,000. So there are 1,300 in the vaccine arm and 660 in the placebo arm. So there weren't enough severe cases to be able to look at it, but the fact that it was 91% effective at preventing any COVID is really, really good for a couple of reasons. One, it keeps the kids safe, which is ultimately one of the major reasons that we're interested in this. But then the second is that it prevents them from getting infected and prevents them from spreading it to other kids. So presumably once they get vaccinated, then soon after, once the vaccination rates are high enough, then presumably we won't need to worry about them wearing masks in school and worry about that stuff as much. So then they can go into class and without fear and without having to have all these mandates and stuff in place. So that'll make a big difference, and they'll be less at risk of infecting the people that they live with, catching something at school and bringing it home. So that's also good news. 91%, very strong, very good news. So that's why, based on the safety and efficacy data that we're seeing here, it's very likely that we're going to see approval from the VRB pack and from the CDC.
So then that means emergency use authorization, right? And then how soon after that do you anticipate that this vaccine will be fully authorized?
Yeah, that's a really good question. So in order to get full authorization for adults, the CDC and FDA required a total of 6 months of real world data to be able to see what was going on at the 6-month period. So it'll likely be the same. It'll require a 6-month window to evaluate. So that means it'll be some point after 6 months because you need to collect the data for 6 months and then study it. In terms of the 2 months, why is 2 months important? So for every vaccine in history ever studied, all of the adverse events were found within the first 6 weeks of the clinical trials. And that's why simply looking at 8 weeks of data is typically sufficient, because anything that we would have found already. So if we didn't find it here, it means it's very likely that we're not going to find it going forward. So that's why there's not much concern about that.
So that right there was our talking point to anybody who says, well, I don't know, I'm just going to wait and see, right?
And that is, in fact, there's a poll here that's interesting. This one, I might have shown this previously, but it's still an oldie but a goodie. So this is asking, among parents of kids age 5 to 11, how many will vaccinate their kids? And so around a third are saying for kids 5 to 11 that they will vaccinate right away. And then another third are saying wait and see, which is unclear exactly what that means. I mean, maybe they're just waiting to see for emergency use authorization. So maybe we're talking almost 2/3 who would very quickly do it. I don't know. But then you have these greens. You have roughly a third of the people who will only do it if they are absolutely required in order to attend the school. And there's probably going to be wide variation in terms of schools requiring the vaccine. And then there's, on top of that, around a quarter who say definitely not, that even if it's required, they won't allow their kid to get vaccinated. And I don't know how to interpret that. Does that mean that, I don't know. I don't know what that's going to mean. Because if the kids are no longer wearing masks, does that mean that if they're vaccinated that they don't have to wear a mask, but if they're unvaccinated, they will? Or will all the kids still have to wear the mask because of the 25% who refuse to get vaccinated? Or I don't know. I don't know what this is going to look like yet. But that's, yeah. We do have vaccine requirements for all sorts of vaccines for kids. But there's this huge polarization thing going on here in society. And so I don't know how this will play out for kids. That's all the politics of it, which I can't see what that looks like yet. Just a couple of things you might be interested in also seeing. I don't know if we touched on this last week, but these are the side effects in kids. So when you're looking at kids 5 to 12, this is the 10 microgram dose. This age 16 to 25 was the 30 microgram dose. but let's just focus on the 5 to 12 for now. You can see, well, first, the first thing you can see is that compared, so the 5 to 12-year-olds compared to the 16 to 25-year-olds, you can see that in general, the side effects were far less. When you look at every single side effect, they tended to be less for the younger kids, which is good news. And when you look at the 5 to 12-year-olds compared to the placebo, they tended to be very, very similar. So when you look at here's 2.5% to 1.3, 33% to 31, 22 to 24, it's very, very similar, which means that there's probably not going to be a huge noticeable difference among for people who get infected. It'll be almost as much as simply just getting the placebo. And so that's really good news for the 5 to 12-year-olds. This was the primary reason why there was the decision to use the lower dose, because you could get roughly the same amount of efficacy without having the severe side effects. But even in terms of, I just used the word severe, we don't really see severe side effects here. We're really only seeing mild side effects and a little bit of moderate. But any side effect that you see is almost entirely mild, and particularly among the 5 to 11-year-olds, it's almost entirely green. It's almost entirely mild. This is the systemic events, which is typically the most concerning and what we mostly focus on. But then also over here are the injection site reactions. So for instance, where they get the shot, is there redness, swelling, or pain, persistent pain at the injection site? So the one thing that does continue here that we see is there does continue to be a little bit of pain at the injection site. It does tend to be very mild, and it occurs in roughly the same, a little bit less than people who are older. So that comparing the 5 to 11-year-olds versus the 16 to 25-year-olds, you see that it does occur at a fairly large percentage of them. I don't have a placebo comparison here, so I'm not quite sure how it compares, but you see that there is something. Oh, here's the placebo, it's right next to it. So you see when you compare it to placebo, that it is a fair bit larger than the placebo. But again, the vast majority of this is very mild. There's like virtually no severe cases that you see here. So it's bearable, but it's still going to be something that they might complain about for the day or two. But again, this is just pain at the injection site, which they can take a NSAID for, so Advil, Tylenol, something like that, just for the injection site. Don't do it prophylactically. Do it after they start to complain about it. It's probably fine at this point. But the other things you might be more concerned about, we aren't going to see much of that in terms of the fatigue. We'll see a little bit of fatigue and headache, but roughly at the same rates that we would have seen just from placebo. So nothing to worry about. And
Great data, Glenn.
Thanks. And that is that for the kids.
Great. Thank you. So let's move from the kids vaccine to the booster shots. Lots in the news, lots of conversation about the boosters. Who is eligible? How safe and effective are they? Should people mix and match? Tell us what we should do with boosters.
All right. By accident, I separated out my booster discussion. Let me talk about here, because this slide is open first, so I'll just discuss this. So in terms of the side effect of boosters, this was an ongoing question. We saw that there was a very, very, very low risk, but it existed. It was a risk that existed for myocarditis, so inflammation of the heart. But it was extremely low risk. But so we've been tracking to see, first of all, how common is it among people who got their first dose or second dose, and then how common is it in the third dose? You can see that among people who got, this is Israel data, and they used Pfizer. So this is Pfizer data in Israel. You can see that the rates were extremely, extremely low. So for instance, among women aged 20 to 24, there was one reported case out of 264,000 people who got it. The highest, but the usefulness of breaking it down by gender and age is then you can look to see if there's any age groups or gender combinations that are at highest risk. And what we found are that in the second dose, that we really had people aged 16 to 19, or even aged 16 to, let's say, 30, this cluster had a much higher likelihood of heart inflammation versus the other age gender groups. We're not exactly sure why it is yet, But what we do know is that it's mostly nothing to be concerned about. It's self-resolving in the majority of cases, even without treatment, without anything to worry about. A lot of these kids don't, or a lot of these people don't even know that they have it. So unless you look for it clinically or subclinically. And the rates, again, are really low. So a rate of 10 out of 150,000 is still a pretty low rate of something that's not so severe. So the question is, well, how often does it occur in the third dose? And you can see that in the third dose, it's occurring at a much lower rate than it did at the second dose. And we're not exactly sure why that is. I mean, a couple reasons come to mind. I don't know if people were excluded from getting a third dose if they had a higher, if they had myocarditis in the second dose. That might be, and if that's the reason, then you might just be selecting the people out who had any susceptibility to it. I didn't look closely enough here. But another reason could be that the first dose and the second dose were given very close to each other. I think was it like 21 days apart or so generally, whereas the third dose was given at least 6 months afterwards. And so it could be that simply by separating the days, the length of time so long between the doses, that itself might have just been sufficient to prevent the myocarditis. But whatever the reason, we are seeing in booster, or we are not seeing in boosters anything to worry about. And so we're not seeing the myocarditis. We would, if it existed, we're looking closely enough that we would find it. But the fact is, we're just finding it at very, very low numbers that are not really anything to be worried about. So now let me look at the booster question more generally, which is up here. All right, first, so we just got new data from Pfizer this past week. And what Pfizer reported on was efficacy. And so what they did was they compared people who got the booster shot of Pfizer with people who only got the 2 vaccines. So they had originally gotten the 2 vaccines, but they didn't get the booster. So how does the booster compare to people who got fully vaccinated but did not get the booster? And what they found was that the booster provided an additional almost 96% protection versus people who are fully vaccinated. So we have found that the vaccine effectiveness has dropped a little bit over time, especially with Delta. This trial that they just reported on this past week, so October 21st is when they published it. This was all during Delta when they were investigating this, and the booster provides an additional 96% protection over people vaccinated. So this is not absolute. This is whatever the previous protection was, this is 95% on top. So I wouldn't say that it makes you bulletproof, but it's almost as good as calling it bulletproof in terms of how effective this is at protection. And so that's really good news. So that's first. So this is Pfizer. In terms of who's eligible, the Moderna is emergency use authorization is now going to be the same as Pfizer. So again, this is anyone age 65 and over. All adults who have these comorbidities that increase their chances of severe COVID if they get it, complications. Anyone age 18 or over in some of these high risk areas for facilities, homeless shelters, long-term care facilities, etc. And then people who are at high risk of exposure or spreading it to others if they do get infected. So for instance, healthcare responders, first responders, teachers, etc. The Johnson & Johnson vaccine is a little bit different. And that's because we found that the Johnson & Johnson vaccine is less effective over time. And it wasn't as effective to begin with. It was great. It was much, much, much better than nothing. And in fact, a lot of people probably got the J&J vaccine because they only had to get 1 shot. So it was still useful. It still filled a niche. However, getting a booster is very important at this point for everyone who got Johnson & Johnson. What they're saying is that anyone who got Johnson & Johnson at least 2 months ago should go and get it now. With Pfizer and Moderna, it's 6 months ago, but now Johnson & Johnson, they're saying anyone 2 months ago. Every single person who got Johnson & Johnson is now eligible at that 2-month period for getting the booster. The question now is, I'll just jump into this because it's the next slide. Should we mix or match the booster shots? This is a really important question that a lot of people have been having. Here's the data There's different studies coming in. Some of these studies are somewhat small, but they tend to be pretty consistent in the answers. And they've occurred around the world now. There's been a bunch of these different studies. And so up here are the initial vaccines. So this is the Johnson & Johnson vaccine, Moderna, and Pfizer. All right. So now the question is, if you got the Johnson & Johnson vaccine or Moderna or Pfizer, but then get the Moderna booster, how much does it improve your efficacy? And what you find here, if you look down, the key thing is down here at the bottom. If this is the key number is this 2,800 number compared. So if you originally got Johnson & Johnson, the one shot, then you got the Moderna booster, you now have 2,800 quantity. This is the quantity of immunoglobulin G serum binding antibody. It's binding antibody units per milliliter is how to interpret that number, 2,800. However, if you originally got Moderna and then took Moderna, now you have 5,900. If you originally got Pfizer and then got Moderna, now you have 5,100. So clearly, getting Moderna is great compared to so that's a starting. Now let's say you originally got something and then got the Johnson & Johnson vaccine. So say you originally got Johnson & Johnson, then took Johnson & Johnson as the booster. The problem is it raises it, but it only raises it to 368. That's far, far less than what you see the Moderna boosted it to. So therefore, just based on this, if you're looking strictly at efficacy, it probably makes sense to, if you originally got Johnson & Johnson, to get the Moderna shot. Now, the one thing is the Moderna booster used in this study was 100 micrograms, whereas the Moderna booster that's approved in the emergency use authorization is 50 micrograms, half the dose. So simply having larger volume probably increases your antibody level. We think that has a pretty big impact. So, but even still, the order of magnitude between Johnson & Johnson and then getting a second Johnson & Johnson versus Johnson & Johnson and then getting Moderna is so large, it still probably makes sense to get Moderna. What if you got Moderna first and then Johnson & Johnson? Well, look at that. That has a major impact. So the Johnson & Johnson used as a booster is still pretty strong. Not quite as strong as Moderna, using Moderna as a booster, but it still provides a really huge response. Because if you look up here, this is day one. So this is before you've had any real impact based on the booster shot. So if you went from 630 all the way to 4,560, then clearly having the J&J vaccine after Moderna still is very useful to match it that way. However, if you started with Pfizer and then go to Johnson & Johnson, it's not nearly as high as what you would have gotten if you had originally gotten Moderna. We don't have all the data here at 29 day, but if you look at day 15, so this is 2 weeks after it, which is still a reasonable time point, and look across, among people who originally got Pfizer, if the question is, you originally got Pfizer, do you get a booster shot of Pfizer? Well, at 2 weeks' time, you can see the booster shot would have given you 3,400 antibodies relative to the per mil. And if you decided instead, if you'd originally gotten Pfizer, but then you got a Moderna booster, then instead of 3,400, it likely would have bumped you up to 6,150. So clearly switching from Pfizer to Moderna gives you a big boost versus if you had just stayed with Pfizer. Similarly, but in contrast, it's not quite the same if you were Moderna switching to Pfizer. So here's Moderna at 2 weeks is 6,800, which is quite large. If you had switched and gone from Moderna to Pfizer, then that's still a big bump, far larger than the other ones, but it's not quite as high as the Moderna to Moderna. So either way, you're not in bad shape. If you started with Moderna and got any booster, Pfizer or Moderna would have done well. But for a lot of people at this point, simply getting the Moderna booster seems like it does well. But again, this study is only looking at the 100 microgram dose, whereas the booster that's actually approved is 50 microgram dose. So that's probably going to have a little bit of an impact, and the antibody levels won't be quite as high. I think I have a little bit of data here. This was looking at neutralizing antibodies, and it's the same story basically here. So this is if you boost with the Moderna, regardless of whether you start, this is Johnson & Johnson in the first one, Moderna is the second, and third is the Pfizer. When you boost with Moderna, everything comes up to this order of magnitude. It's relatively the same. When you boost with Johnson & Johnson, not all of the data is in yet. So if you just look at the second week, it doesn't quite hit the same level that you would have hit with Moderna. And if you started with Pfizer, it gets close. Again, the data is not quite in yet, but it gets pretty close to where we were, but maybe not quite as high, but probably order of magnitude is sufficiently high that in terms of real world evidence, in terms of the effectiveness, it would probably be roughly the same. Because it probably, if you're looking here at like whether you have 5,900 antibodies versus 5,100 antibodies, those are probably the same. It's the same order of magnitude. So it's probably in real world effectiveness, it's probably going to be the same type of thing we'd see in the real world. So we wouldn't have to worry about it. Anyway, that's what I have here. Do you have any other questions about booster or mixing and matching or anything?
Sounds like more to come, right?
Yeah.
As this data is being developed and delivered, more to come. In the next few weeks when we meet again, I'm sure you'll have even a deeper dive with this mixing and matching.
Probably.
Excellent. Well, thank you. This is really informative. So you touched upon it a little bit earlier about the Delta Plus, and you showed us, why we don't really need to be worried about it so much. Did you have anything else you wanted to add to that? Okay.
Yeah, I'll talk about it just a little bit. So Delta Plus, it's also called AY.4.2. It's just a grandchild or child of the Delta. And so this one, it looks like it's starting to spread a little bit more in the United Kingdom, where it's making up around 10 to 15% of the cases at this point. That might be partially why we're seeing some more cases that we just saw earlier. We're not sure yet. It's also been identified in Israel. It's been identified in the United States. It's been identified in some other countries. But we're starting to track it, but we're not really we're so concerned about it. Like I said, Delta itself is so contagious that it's sort of like hit this threshold that everyone's going to get infected. There's no way to avoid it at this point. Better to be infected after being vaccinated, because then you don't really have the symptoms. The severity of the disease goes way down. But in terms of how contagious it is, it's right now we're following it, but we don't really see anything else. All right, let's go on. Let's go to a different question.
Okay, we'll leave that crazy grandchild aside. Does anyone here know anything about that? Just wondering. Okay, so let's move on to, if you could refresh our memory, please. A question has come in about long COVID and how many people likely have it now and what causes that?
Yeah, that's a really good question. Let me just jump into it quickly. So let me go here. So yeah, so our estimate right now is that around 1 in 3 people, it varies. A lot of the studies are coming back all over the place. That our estimate is around 1 in 3 people have long COVID. But more interesting is a lot of people, their symptoms completely go away. But then in 3 to 6 months after the infection, for 2 in 5 of people who end up with long COVID, they get long COVID symptoms only after 3 to 6 months have passed. And that's odd and unfortunate. But that's probably because the antibodies, among people who are naturally infected, the antibodies evolve in their body over time and change over time. And so they might change into antibodies that become more harmful to their bodies over time, more autoimmune. If you recall, there were 4 hypotheses of what causes long COVID. One could be that there are persistent chronic infection going on that's hiding out in some organ. There's a little bit of evidence for that, but I don't think it's super compelling. The second is that when someone's infected, it causes structural damage to some of the organs. And so maybe like scarring or other types of things. And that has some evidence for it, but I don't think that is describing what's going on in most of the people with long COVID. The third is that it's triggering the immune system. And so maybe you just have persistent levels of some of the cytokines and stuff independent of anything else. And maybe that's what's going on. We do see a little bit of that, but I don't find that super compelling. The thing I find most compelling is this. So among people who are naturally infected, if you recall, the spike protein binds to the ACE2 receptor. And the ACE2 receptor normally, when it's not worried about the virus, normally the ACE2 receptor binds to the ACE2 enzyme, a naturally occurring enzyme. And the ACE2 enzyme is responsible for controlling blood pressure, blocking organ damage. It prevents vasoconstriction, so constriction of the blood vessels. It prevents fibrosis, prevents inflammation, oxidative stress. The ACE2 enzyme is really important, or rather, get the ACE2 enzyme in terms of its action is important. When you have an antibody that thinks the ACE2 enzyme is the same as the spike2 enzyme, then presumably you're developing an autoimmune disease. And so you might have antibodies that pull the ACE2 enzyme out of the blood. And so then that could be what's causing all of these symptoms. And I think that this has some fairly strong evidence at this point. I'm not going to get into too much about that. I think we've talked about it a week or two ago, but or a time or two ago that we met. But for me, that's what I'm betting on. I think that it sounds most likely. The spike2 protein evolved to look just like the ACE2 enzyme, so it would make sense that the body gets confused. In contrast, the vaccines were designed specifically to prevent it from binding to the ACE2 enzyme. And that's why the vaccines are so effective at preventing long COVID. And even among people who get long COVID because they were naturally infected and then get the vaccine after, in around a third of them, their long COVID symptoms go away. So that's why even people who are infected should get it. But now the question is, these are long COVID is defined by the symptoms. The problem is, if this mechanism of action is really going on, then people could have a deficiency of ACE2 enzyme that's subclinical, and they may end up having some of these problems. So with blood pressure control and inflammation and oxidative stress, that's not triggering symptoms, but that's causing subclinical stuff. And that could be concerning and something that we're going to need to look for. Anyway, what we're seeing right now is that in roughly 1/3, from some cohorts, we're seeing it a little bit less than others. People who are hospitalized are far, far more likely to have been to get long COVID. So for instance, when you look at people who were in Wuhan, China, among the original people who got infected in Wuhan, China in 2019, almost half of these people are now suffering from long COVID. Among the survivors, almost half are now suffering from long COVID. So that's really disconcerting. Another really important reason to get vaccinated, whether people have been infected or not. So those are the numbers. But like I say, because if this hypothesis is true, and what's really going on is it's something to do with the ACE2 enzyme, then there could be subclinical things going on that we'd need to worry about and track that the symptoms. Because again, if this is really going on and people have increased inflammation, increased fibrosis, whatever, this could be explaining in some of the other studies that we've discussed previously how some people have an increased risk of heart attack or stroke after recovering from COVID-19 more than you would have expected. And this could be what's explaining part of that. And so this is definitely something we're going to be looking at more.
Thank you for explaining that, Glenn. Your diagrams, as always, are very useful in following along. I'm so glad one of us paid really close attention in bio and chemistry and all those good things.
Yeah.
Okay, so you just touched upon Wuhan, and it's so unfortunate, how sad that so many there are still suffering from long COVID. We are at the top of the hour, and so maybe we can end with you sharing your thoughts about, there still is conversation about the origin of this crazy virus, and are you still so convinced that the original COVID-19 originated in the wild?
Yeah, that's a really good question. So most epidemiologists are almost certain that this is of natural origin, but not certain for sure, because there's always the plausible possibility that it came from a lab. So let me dig into that a little bit. So first, I'll dig into this. So first, origin stories. So now, even if it wasn't necessarily mad scientists who created a virus in a lab. It could have been in the process of taking all of these blood samples and saliva samples and fecal samples from bats all around China, that in the process, maybe some of the people infected there got infected in that process and maybe brought it back to Wuhan. Or maybe some of the people who are studying the bats, maybe they came into contact with some of the local people who lived near the jungles where the bats were, and the people infected them. Because we know, or rather we estimate now with pretty good evidence from some of the work the EcoHealth Alliance had done, that approximately 1 to 7 million people are exposed to coronaviruses every year in these areas where they found these bats with the coronaviruses. So that's a lot. Now we know in the United States, for instance, these surges, once people all mostly get infected, then you don't really have the surges anymore. You have this immunoprotection. If a lot of these local people who live in these rural areas, isolated from other people, if they mostly got infected over the last 5-10 years, they would have some sort of some level of immunoprotection among them. People who live in these rural communities tend to be a lot younger than people who live in the cities. And we know that people who are younger tend to have only cold symptoms from it. It's really the old people who get sick. And guess what? People living in the jungle without healthcare tend not to live to very old anyway. And so maybe the people who live there tend to just not spread it very much, and that's why we haven't had outbreaks. But then the people who are the visiting researchers shook the hand of the people who live there, and maybe they got infected, and that started it all. We found that so there's a lot of ways, a lot of pathways in which this could have happened over time, and none of it wouldn't necessarily have been because of some sort of gain of function research in the lab. But it could have still been through the process of doing the studies, these very, very important studies, that this happened. Still, a lot of epidemiologists say, no, we don't even think that's the case. And why is that? Why don't we think that's the case? And the main reason is that these viruses emerge all the time in what we found. So for instance, not just looking at coronaviruses, forget other epidemics that have occurred and other outbreaks of Ebola and all these other things. Simply looking at coronaviruses, in 2003, we had SARS-CoV-1. That was the original SARS epidemic. And then in 2012 or so, 2013, we had MERS, the Middle Eastern respiratory outbreak. And then now, so we were all thinking within another 5 to 10 years, there'd be another natural outbreak. And lo and behold, there was. So a lot of us were fully expecting it. But now, there's even more evidence that's come out. And so people have been looking at bats and other animals to try to find similar viruses. We haven't found an exact match yet, but what we have found in Laos and in southern China, far away from Wuhan, is some bat coronaviruses, so different species of coronaviruses, not exactly SARS-CoV-2, but getting closer, that are very similar. In fact, so there's these two that to pay attention to, this RATG13, and then these over here in Laos, the BANAL 52, 103, and 236. If you compare the RATG13, at first that seemed like a really compelling candidate, and RATG13 shares 11 of the 17 critical parts of SARS-CoV-2. So it seemed like that was a really close cousin. And then if we just look closer somewhere around here, around where that was found, that you'd probably find the original SARS-CoV-2. But then we found even closer in Laos, we found that they had 16 of 17 critical building blocks were the same. So we think, we don't know, we haven't found the identical SARS-CoV-2 yet, but we think we're getting closer. And 16 of 17 is far, far closer than anything that we found in the original China Wuhan lab. So that's really important to know. That's largely why people who are epidemiologists or virologists, our gut is telling us, well, there is certainly still a possibility. We don't know for sure, but the most likely scenario by far is that it's natural origin, of natural origin. Frequently, so people might say, well, why were the first cases found in Wuhan? And the primary reason for that, there's two quick answers. One is that in virtually all outbreaks, the outbreak in people is first noticed far away from where it occurred naturally, because people move around and you don't actually see it start to blossom until people move around somewhere. So for instance, the original SARS-CoV-1, so SARS in 2003, it was found way, I don't remember exactly, but many miles, hundreds of miles, thousands of miles, I don't remember exactly how far, but far away from where the outbreak first was identified. MERS was found far away. Ebola is frequently found far away. There's a lot of outbreaks where we still to this day don't know where they started, and it was nowhere nearby that they started. So another reason is that Wuhan, because it's a major area of study, if an outbreak were to occur, they'd be the very first to find it. So it makes sense that if there were these small outbreaks in some other places, like, so for instance, I was talking about the jungle, if there were small outbreaks in these communities, you'd almost certainly not find it, because first of all, the majority of them would just get cold symptoms, and so who cares about that? And then the few that died, there's a much higher death rate there in general for older people, so it would have been overlooked. There's not really any hospitals there to even find it. And so by the time it would actually spread, you'd expect it to be among people going to the meat markets or going to Wuhan, and that would be totally plausible. One other thing has come to light, and so I'll bring this up. That's not that. Nope, that's not that. So the Wuhan mad scientists theory, the gain of function. So what was reported on, but two things have come to light. One is that there was a 2018 grant proposal written by EcoHealth Alliance to do gain of function studies. The gain of function study, first of all, was supposed to be done at UNC Chapel Hill, at UNC in the United States. And so that's first of all one of the things done. The grant never happened, but even this grant wasn't supposed to occur in Wuhan. If it were funded, it would have occurred at UNC, and it was not funded. But then the next thing that's come out is that it seems like there might have been some gain of function studies. So there's typically these things called gain of function versus loss of function, where you just change one or two enzymes or different things to see what the impact might be. But even that is not changing enormous code. You're just changing these one little parts. And so what they found is that even with this, in Wuhan, the very closest species of coronavirus that they had to SARS-CoV-2, what they reported was that that code was still over 1,000 differences in terms of the underlying parts of the code versus what was found in the SARS-CoV-2 virus. And so it was still quite different. But there's still, you don't know for sure. There's still this possibility that something was going on that we just don't know about, but it's just extremely unlikely. One thing I'll just say before closing this is, well, two things, and I'll just say this, and then I'll go on to the final statement. But so first of all, there's a new funding that was that's been given by the United States now to this organization USAID, so part of the United States, and we're going to be funding this project called USAID Discovery and Exploration of Emerging Pathogens. So we're funding around $125 million over 5 years to search for previously unknown pathogens in the coronavirus family, in the Ebola virus family, they're called filoviruses, and then in these other things called paramyxoviruses. I can't pronounce that very much, which is what measles is part of. And so these three are seen as some of the potentially, because they're mostly respiratory. I guess Ebola is not generally respiratory, but because these tend to be very contagious and deadly, these are what we're looking at. There's 12 countries that are going to be targeted in Africa, Asia, and Latin America that we're going to be partnering with. We're expecting that over the 5 years, we're going to collect over 800,000 samples from bats and other wildlife. And we're going to be hoping that we're going to find 8,000 to 12,000 novel viruses. The tricky thing about this is that we now potentially have over a dozen other Wuhans, because previously the EcoHealth Alliance that we were doing similar work with, they were partnered with the Wuhan Institute. Now we're going to be partnering with institutes across 12 other countries. And so there is a potential now that there will be other outbreaks. And guess what? In any other outbreak, there will be people who have these conspiracy theories who say, oh, it was the partnership that caused it rather than simply looking for the virus that enabled us to find it too. Because when you find these 8,000 to 12,000 novel viruses, say in another 5, 10, 20 years, when we have a new outbreak, presumably we will have found it already and we'll have it already in a lab somewhere. But that just because it's in the lab doesn't mean that the lab was responsible for it. All it means is that we did good work in finding it. And but the conspiracy theories are going to come. But that's something we can say with 100% certainty. One final thing, I just want to give you to shift your intuition. If your intuition isn't quite there yet about the natural origin likelihood versus something happening in the lab in Wuhan, let me give you an intuition pump. All right, so say that you have a millionaire who is your neighbor nearby, and you don't know how they made their millions. You might say, well, maybe they're a millionaire because they won the lottery. Or you might say, well, maybe they're a millionaire because they are in the finance industry, or they went and became a physician, or they went to and became a publisher of a great book series and became a millionaire that way. There are many different ways to become a millionaire, and winning the lottery is only one of those ways. But someone could be convinced that their neighbor is a millionaire because they won the lottery. And so they might say, well, they might look at the evidence, and they might say, well, I know for a fact that the neighbor plays the lottery and is very interested in the lottery. And I know, or did when they were younger. And I know for a fact that a winning ticket was in their zip code. And I know for a fact that the winning ticket was in their very convenience store that they go into every week. And they might say, and I know for a fact that there was so much other evidence that they either played the lottery or were very likely to have won the lottery. But just having that evidence that's all just anecdotal doesn't tell you that just because they're a millionaire that they won the lottery and that's how they got their million. So for instance, for an epidemiologist, what we'd say is, well, how likely is it? What percentage of people who are millionaires became a millionaire because they won the lottery? And it turns out that number is something like 1 in 1,000. If you know that someone is a millionaire, there was roughly a 1 in 1,000 chance that they became a millionaire because they won a lottery. And so from our perspective as epidemiologists, we'd say, we don't care about the anecdotal information. That doesn't tell us anything. The bigger question is, given that they're a millionaire, what's the likelihood that they became one from the lottery? And we'd say 1 in 1,000. It was a really, really, really low likelihood that they became a millionaire from winning the lottery. It's plausible that could have been how they became a millionaire, but if it's only a 1 in 1,000 likelihood, it's so low a risk. It was much, much more likely they worked hard or they inherited the money, or for some reason they became a millionaire. Far more likely it was some other reason. That's why our intuition, when we talk about Wuhan versus naturally occurrences, that's our thought process. That's why we think, okay, it's plausible, it's possible, but very, very unlikely that Wuhan was responsible. But we know there are so many other plausible possibilities of where it came from that it is far, far, far more likely that it's one of these other natural sources that it came from rather than from a lab in Wuhan. And that's why an epidemiologist or a virologist intuition is in a very different place than where a lot of these articles are that people read in the news, or for people who are thinking about the conspiracy theory. Again, one more time, going back to this winning the lottery, any evidence about the lottery doesn't inform the likelihood, because all it does is inform our story. It just informs the intuition. It's an intuition pump. It doesn't tell us how likely it is. And when we think about this, we really have to be thinking about the other side of the equation, and that there's 999 other millionaires for every 1 millionaire that won the lottery who got their millions in totally other ways. And so we really have to recalibrate what our intuition is when we talk about these things.
Very interesting, Glenn. And there you have it, folks, an epidemiologist's view on the lottery and comparing that to what we're learning about the origin of this dreadful disease, this dreadful virus. So very interesting, Glenn, and that definitely, your story definitely resonated with me. And so thank you for sharing that example. I think that was really, really interesting. Thank you to everybody for sending in your great questions. Keep them coming. Glenn, when are we meeting again?
So I think we said 2 weeks from now. Is that right, Rebecca? I know
Okay.
that you can't make it then. Or did you prefer 3 weeks from now? I'm
Yeah,
either way.
I'm available 3 weeks from now, not 2 weeks from now, but
All right, so
I'll leave that in your hands.
let's do it 3 weeks from now, which is so next week is Halloween. The week after is the 7th. You want to plan for the 14th, November 14th?
14th it is.
All right, everyone.
So mark your calendars, everybody. Keep sending in your great questions and continue to stay healthy, well. Watch out for your crazy grandchildren, like that Delta Plus, and we'll see you in 3 weeks. Thank you, Glenn.
Thanks, everyone. Thanks, Rebecca. Have a great 3 weeks. All right, bye-bye.